Alright, so in this video we're going to talk about other types of reactions. Now, the first type of reaction we're going to talk about is a single replacement reaction. So this is where you have one element, it's going to replace another element in a compound. So basically the compound will always be in some sort of aqueous solution. So just like a double replacement reaction, it happens in solutions. Single replacement reactions also happen in solutions, but the element will be a solid or liquid or a gas, and then it gets added to an aqueous solution of a compound, and basically it can replace an element in a compound and then it pulls the other element out by itself. So if you have a metal and you place it with an ionic compound, the metal can replace the metal ion. If you have a non-metal, it can replace the non-metal ion in the compound. So here's an example. We have copper that's by itself plus a compound, and what ends up happening is the copper will switch places with the silver and it pulls the copper into the solution and then the silver out. So what you'll end up seeing is you'll actually see the silver come out of the solution, and you actually create, or you pull the silver out and make a solid silver. Alright, so in order for this type of reaction to happen, the free element has to be more active. So it's going to be higher on the activity series. So here's our activity series. Basically, it's like a ranking. Lithium is the most active metal. So it can replace any of these elements below it. So if you have lithium by itself and it's reacting with a compound, it can replace any of these metals below it. So you're always comparing the thing that's by itself to the metal in the compound if it's a metal. If it's a non-metal, you're going to compare it to the non-metal. Now, halogens are not on this list, but halogens are also, there's also an activity series for halogens, but basically if you just look at the order of the periodic table, it works the same way. Fluorine is on top of the column, so fluorine is the most active of all the halogens and can replace the other halogens one. Okay, the first thing you do is you say, okay, I have this thing by itself plus this compound. This is a metal, so I'm going to compare it to the metal in the compound here. So I need to check the activity series first. So I'm going to go back. I had magnesium and copper. Here's magnesium, and here's copper. So magnesium is above copper, and since it's the metal that's by itself, the reaction will happen. So magnesium can replace copper and pull it out of the solution. So what you end up creating is copper as a solid, because you're pulling it out of the solution, and then magnesium will now bond with sulfate. So magnesium is a +2, sulfate is a -2. Always check your charges and figure out the formula that way. Alright, so it's MgSO4, and it should be an aqueous solution. So this will be aqueous, that's the compound, and then this is also a solid right here. And we're already balanced, so let's look at another one. Let's look at zinc plus silver nitrate. Okay, so zinc is by itself, so we're going to compare that to the metal. Since it's a metal, we compare it to the metal. So zinc and silver, zinc is right here, silver is right here. So zinc is higher, which means that the reaction will happen. So zinc will replace the silver. Silver will be by itself, so you're pulling solid silver out of the solution. And then zinc will bond with nitrate. So -2 or -1 and +2 crisscross, and that's going to be the aqueous. Alright, so now I need to balance. Put a 2 here for the nitrates and then a 2 here for the silvers. Alright, so this reaction does happen because zinc is by itself. It's above the metal in the compound. Alright, so let's look at this one. I have silver by itself, and so that's metal. I'm going to compare it to the metal in the compound, zinc. Okay, so silver was the one by itself, which is right here, and zinc was in the compound. Well, that means that the reaction will not happen. So since silver is by itself here, it is not going to react to the zinc nitrate. So that means no reaction happens. So the thing that's by itself has to be higher. All right, so in this case, there's no reaction. All right, so let's look at another one. Let's look at Cl2 plus sodium iodide. Well, Cl2 is by itself. This is a non-metal. So you look at the non-metal in the compound, which is iodine. These are both halogens. So what you do is you look at your periodic table. So your periodic table, fluorine is on top, then it's chlorine, and then iodine is more towards the bottom. This is higher, so the reaction will happen, and it will replace the non-metal. You can only replace the non-metal here. Please do not put sodium out and then try to bond the iodine and the chlorine. That's not going to work. So the thing that's by itself now will be the non-metal in the compound, so it's I, but it's a Brinkelhoff, so it's I2. And then the compound will be sodium with chlorine. So check your charges. It should be NaCl. And this will be aqueous, and then iodine will end up being a gas. So not a solid because it's one of the halogens. It's a gas. And this is also aqueous. All right, so combustion reactions are very, very simple. So if you have a hydrocarbon that's combusted completely with oxygen, then the products are always going to be carbon dioxide and water. So if you have any hydrocarbon at all, you could have this and oxygen gas. You're going to get carbon dioxide and water. Very simple. All right, so decomposition reactions occur when there's one reactant. So if you see one reactant, it's going to decompose. So if you have a binary compound, which is just two elements, it's just going to decompose into its elements. So we have potassium bromide here, so it's going to decompose into potassium, and also bromine. But since bromine is a Brinkelhoff, it should be Br2. Okay, so we have some more complex decomposition reactions. You need to know these rules. So if you have metallic carbonate and you heat it, you're going to make a metallic oxide and carbon dioxide. If you have a metal hydroxide, when it's heated, it's going to decompose into a metal oxide and water. Metallic chlorate will decompose into the metal chloride and oxygen gas. A metal sulfate will be the metal oxide and sulfur trioxide. And most nitrates will decompose to make a metal oxide, nitrogen dioxide, and oxygen gas. All right, some other decomposition reactions. If you have an alkali metal nitrate, it's going to decompose into metal nitrite and oxygen. Acids will decompose into a non-metal oxide and water. And a metal bicarbonate will produce the metal carbonate, water, and carbon dioxide. All right, so let's look at this. So basically, you just need to refer to your rules. So a metallic carbonate, it has carbonate in it. So let's look for the rule for metallic carbonates. Well, it says that it's going to produce a metal oxide and carbon dioxide. So I know I'm going to make carbon dioxide and then a metal oxide. So what is the metal in this case? Well, it's going to be magnesium. So magnesium bonding with oxygen Charges cancel, so it's just MgO. All right, so now we have a hydroxide, so it's a metallic hydroxide. The rule says that it will decompose into a metal oxide and water. So the metal oxide, well, it's Mg, that's metal, so it's going to be magnesium oxide, and then water. All right, so now we have a chlorate. So if that decomposes, it makes a metal chloride and oxygen gas, so O2. And the metal in this case is sodium, so sodium chloride. Sodium's a +1, chlorine's -1, so it's NaCl. All right, so now if we have a bicarbonate and it decomposes, it's going to make CO2, water, and then a metallic carbonate. So the metal in this case is going to be K, potassium. So K is +1, carbonate is -2. So it's going to be K2CO3. So you just have to know the rules, and then you can just produce the products. All right, so synthesis is where you have one product. So it's the opposite. So if you have a metal and you add it to a nonmetal, that's going to make an ionic compound. So if it's aluminum reacting with chlorine gas, aluminum is just Al. Chlorine gas is Cl2. It's a Brinkelhoff. So now put it together to make the ionic compound. Check charges. Aluminum is +3, chlorine is -1, so it's AlCl3. Like that. Okay, let's look at another one. Or actually, these are the special ones. A lot of these are just the reverse. So let's see. This one is where you make a metallic hydroxide. Well, it's a metal oxide and water. So it's the reverse of the decomposition reaction. Like, this is also the reverse. An acid is made with a nonmetal oxide and water. So when an acid decomposes, it makes a metal or nonmetal oxide and water. These two, you have to remember them. N2 gas plus hydrogen gas produces ammonia. You need to know that. You also need to know ammonia and water will make ammonium oxide, hydroxide. All right, so let's look at this one. Well, it's a metallic oxide plus water. Metal oxide plus water will give me a metal hydroxide. So the metal in this case is calcium. Calcium is +2, hydroxide's -1. So it'll make that. I have a non-metal oxide plus water here. Looks like I'm going to produce an acid. So that's going to be hydrogen plus something else. So I've got SO3 here. What ends up happening is it becomes SO4. You got 4 oxygens here, so it ends up being sulfuric acid. Okay, so basically when you're looking at these reactions, you just need to know these rules.